Well, today we will go over the law of exponents. Sometimes we call the properties of exponents. Sometimes we just call the rule of exponents. Okay, so for today's presentation, I created this table with 9 rules, and we will explore each of them so you be ready or prepare to take college algebra class. So in order to take the college algebra class, you have to know this, or at least you need to review if you took previously. Okay, so let's see. So the product rule says if you have x to the power a times x to the power b is the same as x to the power a plus b. In other words, if you have x, my pen, x to the power second times x to the power cube, for example, so this will be equal to x to the power 2 plus 3, so which will be the same as x to the power 5. Okay, sometimes you will have another situations where you will have something like this, maybe 3x to the second power times maybe negative 3 to times x to the power 4, for example. So in this case, what you will do is you will multiply the coefficients. 3 times negative 3 is negative 9. And you have x squared times x to the power 4. So will be x to the power, you add exponents. So this will be 6. So this will be the solution. Okay. So let's explore the quotient rule. So let's do the same thing, the same some example. So we have the quotient rule says if you have x to the power a divided by x to the power b, so you subtract the exponents a minus b. In other words, let's say that you have x to the power 7, for instance, okay, divided by x to the power, let's say 5. So this will be the same as x to the power 7 minus 5, correct? So in other words, this will be the same as x to the power 2. Bingo. Sometimes you will have a situation like, for example, negative 4. Let me change colors so we can see the difference. So sometimes you will have, for example, negative 4 x to the power, let's say 8 to the power 8. So divide, let's say by 2, let's make easy, x to the power 5, for example. So this will be the same as, so you divide the coefficients for, so negative 4 divided by 2 will be negative 2, correct? So an x will be to the power 8 minus 5 will be 3, so that will be the solution. Let's keep exploring the other rules. For example, we have the power of power rule. It says if you have base x to the power a to the power b, so you multiply the exponents. In other words, if you have x to the power, let's say square or second, whatever you want to call, to the power cube, for example, so this will be the same as x to the power 2 times 3. So in this case, the answer will be x to the power 6, correct? So sometimes you will have, for example, we can have fractions. For example, x to the power, let's say 1 over 2, on this to the power, let's say 4. So this will be the same as x to the power, so you multiply 1 over 2 times 4, and so the answer will be the same as if you multiply the exponent, 1 over 2 times 4 will be 2. So that will be the answer. So again, you multiply the exponents. So we will have situations like in this case with the power of product rule. It means that we have x times y to the power a. So we kind of distribute the exponents. So it will be x to the power a times y to the power a. In other words, let's say that we have x to the power or times y to the power, let's say, cube. So then this will be the same as x cubed times y cubed. Okay. Sometimes you will have situations that involves coefficients. For example, you will have 3x y to the power, to make easy, second. So this will be the same as 3 squared times x squared times y squared. So the answer should be 9x squared y squared. Okay. Now, in the same context, we can have, or we will have also the power of quotient rule. Okay, so what does it mean? It means that if we have x over y to the same power a, we can distribute the numerator with the denominator, and x to the power a over y to the power a will be the answer. So let's do one example. So let's say that I have x over y to the, let's say, power cube. So this will be the same as x cubed divided by y cubed. Okay. Sometimes we will have a little more complicated that involves let's say coefficients. So for example, we will have 2x divided by 3x, all this to the power, let's say, square. So this will be the same as 2 squared times x squared for the numerator. Under the denominator, we'll have 3 squared over, I'm sorry, this should be y. So let's say y squared. Okay. Sorry, my mistake. So this will be the same as 4x squared over 9y squared. Make sure that this originally was y. Okay. So so this up to this point we have a power of quotient rule. Now we will have the negative exponent rule. So this is very important to know. And so for example, if you have x to the power negative a, this will be the same as 1 over x to the power a positive. So when you send to the denominator, this becomes positive. So let's see. So for example, if you have, let's make easy, to the power negative 2. So this will be the same as 1 over x to the second power positive. Now you will, I'm sure you're thinking, where came from this 1? This 1 is right here. Okay. And you can see that this power negative 2 or exponent negative 2 is affecting only to x, not to 1. This is why we have 1 on the numerator. For example, we will have situation like this. I'm gonna change colors. Let's say 3x to the negative power or exponent 5. So you can see this negative exponent is not affecting 3. It's affecting only 2x. So therefore 3 should be in the numerator and divide by x to the power 5. So the 5 becomes positive when you send to the denominator. And also can go the other way around. So for example, if you have, let's say you have 2 over x to the power negative 3 in the denominator. So this x to the power negative 3 we can send to the numerator and will become positive. So will be 2x to the power 3. So kind of like going backwards. Okay. We have another rule. We're going kind of quick. 7, the negative exponent or quotient rule. What does it mean? So we have x divided by y to the power negative a is the same as a y over x to the positive power a. So in other words, let's do one example so that you can see it. So let's say that you have x over y. So to the negative cube. So this will be the same as y over x. So this negative cube, because we flip the x with the y, now becomes positive. Okay. It's like applying the previous rule. Also, you can do this as the same thing. For example, the same thing. You can separate the numerator with the denominator. So it will be x to the power negative 3 divided by y to the power negative 3. So in other words, what we're doing is we're sending to the denominator, and this becomes positive, the exponent, and this we're sending to the numerator, and this becomes positive, the exponent 3. So you can do either way, you will get the same answer, because after this, if you distribute the numerator with the denominator, will be the same as a x cubed divided by y cubed divided by x cubed. Correct? Good. Also the zero exponent, that's another rule. So it says any value to the power 0, it will be equal to 1. So in other words, if we have, for example, if we have 3x enclosed inside the parentheses to the power 0, this will be equal to 1. Okay? But make sure that you identify the difference between this 3x to the power 0, this will be equal to 3. And you will say why? Because this exponent 0 is affecting only to x, not to 3. So in other words, we have 3 times x to the power 0 will be 1. So 3 times 1 is 3. Correct? And the last that that's very important in this class of college algebra will be this rule, the rational exponent rule. What does it mean? It means if we have x to the power a over b is equal to b root of x to the power a. Now, Or also you can write this as a b root of x, all this to the power a. Both are correct translation from rational exponent to radical. Okay, so for example, if you have this x to the power 1 over 2, so this will be actually as a square root. So this denominator goes as the index of the root. So x to the power, this 1 is the exponent right here. So you don't need to write the 1, but the correct translation will be a square root of x. Now, 2 is inside of the radical, is the index, so we don't need to write because we understand that this is square root of x to the power 1. Okay, so let's do another example. For example, if we have x to the power, let's say 3 over 5. So this will be the same as fifth root. So this denominator goes as an index x to the power cube. Or also you can translate as a fifth root of x, all this to the power 3 or cube. Okay? So now I have some of the examples and we will apply all the rules that I introduced to you guys. And let's solve each of this. So we have n times n cubed times 4m to the power 4 times n cubed. So remember this n right here has exponent 1. So we have n times n times n. So we should add the exponents. So it will be 1 plus 3 will be 4 plus 3 will be 7. Okay, now we have times, we took here n, now we need to take here the m to the power 4. So since we cannot multiply n times m, the only thing that we can multiply is the coefficients 1 times 4, because there's 1 there. 1 times 4 will be 4, n to the power 7, m to the power 4. That will be the answer. Okay? What about in here? So this you can solve in two different ways. So for example, this square means that you need to multiply this by itself twice, correct? So in other words, negative 2k squared times negative 2k squared. That's exactly, it means this exponent to this, correct? So now what you can do is, so now you can multiply negative 2 times negative 2 will be positive 4. K squared times k squared will be, we add the exponents, will be k to the power 4. Or also I'm gonna use different colors so you can see the, or also what we can do is this, negative 2 square, correct, and k square square. So negative 2 square will be 4, and we have k, and we multiply the exponents in the power rule of exponents. So 2 times 2 will be 4, and we got exactly the same answer. Okay, so you will see sometimes you can apply one rule before and the other rule after. So it's up to you, depends on how you are mastering this concept. This is a little more complicated, and let's see what we can do in here. So I think if I am you, I will take care first the denominator. So I'm gonna just leave like it is the numerator, so it will be 2y squared times x, correct? In the denominator, I will have this is kind of the previous example that we have seen. 2 squared will be 4, or maybe you need to do step by step. And x to the power -3 squared. Let's see. So this will be equal to nothing to do yet on the numerator times x over this will be 4 and x to the power -3 times 2 will be -6. Okay. Now what we can do is still this x to the power -6 I can send to the numerator. So 2y squared x. This I'm gonna send to the numerator because I have negative exponent. It will be times x to the power 6 positive. In the denominator, I am left with a 4. Correct? Now maybe we can finish up. 2 divided by 4 will be 1 over 2. So in the denominator will be left 2. Y squared, nothing to do because we don't have another y. But we have x to the power 1 times x to the power 6. So this will be x to the power 7. Why? Because we add exponents. Correct? So that will be the solution. Looks like complicated, but before we do anything, think that inside the parentheses we can simplify. So let's see what we can do inside the parentheses. Okay. For example, I still need to open my parentheses and my fraction bar. So look at this, b squared and b squared we can cancel to 1. Also we have 2 right here, 2 divided by 2 will be 1, we can cancel to 1. So what is left up to this point? So we have a squared, and the bottom I have a -2, a cube, that's I'm sorry, my writing, I have to get better skill in this, cube, and what else we have? B to the power 4. See, so now all this to square, right? So now look at this. Still I wanna take care of something inside. Look at this. I'm gonna take care of this a squared over a cube. So a squared means a times a times a, correct? A cube means in the denominator, so will means a times a times a. So if we cancel this a and this a, we will be left in the denominator with 1a. So that's exactly what I'm gonna do. So what is left on the numerator? And the numerator will be left 1 because a divided by 1 or a divided by a is 1. So in the denominator will be 2. So I am left with 1a. What about b? B to the power 4. There's nothing else to do. So a square. So now what we can apply the power rule. So 1 square will be 1, because 1 times 1 is 1. 2 squared will be 4. A squared will be A squared. B to the power 4 to the power 2 will be B to the power 8 because we multiplied exponents, correct? So that will be the answer. Thank you.